Why are Watchpoints so effective at finding hidden bugs? Imagine trying to find a tiny leak in a water pipe. You could check every inch, or you could set a sensor to alert you the moment water starts to leak. That's what Watchpoints do in debugging. They act like sensors for your program's data. Instead of guessing where a bug might be, Watchpoints automatically stop the program when a specific piece of data changes or is accessed. This makes it much easier to catch tricky bugs that hide in the shadows. A watchpoint is a special kind of break in the debugging process. Unlike normal breakpoints that pause the program at a certain line of code, watchpoints focus on data. They pause the program when a certain variable or memory location is written to or read from. This is especially helpful when you suspect a variable is changing unexpectedly, but you don't know exactly where. For example, if a value suddenly becomes incorrect, setting a watchpoint on that variable will make the debugger stop right at the moment it changes. Many bugs happen because data gets altered in ways you don't expect. Sometimes a program writes beyond the limits of a buffer or uses memory that has already been freed. These issues are often hard to see because they don't cause immediate crashes. But setting a watchpoint on the affected memory makes the debugger catch the moment the corruption occurs. This way, you can trace back to the exact instruction that caused the problem. From a debugging point of view, watchpoints save time and effort. They let you monitor data changes without manually inspecting every line of code. When a bug is caused by a subtle change, like a data race or a logic error, watchpoints help you catch it early. You can even set conditions on watchpoints so they only trigger when certain criteria are met. For example, you might want the debugger to stop only when a variable changes to a specific value. This keeps the debugging process focused and efficient. Hardware support in some systems makes watchpoints even more powerful. Microcontrollers like ARM Cortex-M have dedicated debug units that monitor memory without slowing down the program. This is great for embedded systems where performance matters. Using watchpoints in these systems allows you to track data changes in real time without affecting the program's speed. In real-world debugging, watchpoints can be a game changer. If you notice a variable is changing unexpectedly, you can set a watchpoint on it. The debugger will then stop the program exactly when that change happens. This reveals the instruction and call stack responsible for the change. With this information, fixing the bug becomes much faster. Advanced watchpoint features also exist. Some software-based systems can focus on specific parts of data structures or fields. This makes it easier to find bugs like buffer overflows or memory leaks. By watching only the relevant data, you avoid unnecessary stops and keep your debugging session streamlined. To sum up, watchpoints are so effective because they automatically and precisely monitor data changes. They catch bugs at their source before they cause bigger problems. This makes debugging more targeted, faster, and more accurate. Mastering watchpoints helps you fix hidden bugs efficiently and keeps your programs running smoothly.